Look beneath an Australian Bushmaster. Look beneath a Canadian LAV III. Look beneath every mine-protected vehicle the coalition fielded in Iraq and Afghanistan and every armored carrier Ukraine is using to survive Russian artillery today. Beneath all of them, you will find the same shape, a V. The floor of the crew compartment angled downward from the center line, left and right, so that a buried explosive detonating beneath the hull has nowhere to go but outward, away from the soldiers, away from the floor, into the ground and the air and the dust. That V was not invented in Australia. It was not invented in Canada. It was not invented by a defense contractor with a government budget and a decade of research. It was invented in a country that no longer exists, by engineers working under a mandatory United Nations arms embargo, solving a problem that was killing their soldiers every week. The country was Rhodesia. The year was 1974, and the vehicle they built, the Casspir, would go on to save more lives than any single piece of military engineering in the second half of the 20th century. To understand why Rhodesia built the Casspir, you need to understand what Rhodesia was and what it was facing. In November 1965, Prime Minister Ian Smith declared unilateral independence from Britain. The United Nations responded with mandatory economic sanctions. By 1972, Zanla and Zipra guerrilla forces, supported by Mozambique and Zambia, were conducting an intensifying insurgency across Rhodesia's borders. The weapon they used most effectively was the landmine. Soviet and Chinese-supplied TM-46 anti-tank mines, buried in the red dirt roads of Rhodesia's operational areas, were destroying Rhodesian army vehicles and killing soldiers at an accelerating rate. In 1972 alone, landmine incidents killed more Rhodesian soldiers than all other causes combined. The Rhodesian army was driving Land Rovers, Bedford trucks, and South African Unimogs, flat-bottomed vehicles. When a TM-46 detonated beneath a flat floor, the blast wave had nowhere to go. It went straight up, through the floor, through the soldiers sitting above it. The solution that emerged was not obvious. The first instinct was to add armor, put a steel plate beneath the vehicle. The plate absorbed some energy, but transmitted the rest directly upward. Soldiers were still dying. Then a Rhodesian military engineer, working with the South African Council for Scientific and Industrial Research, ran a series of tests with different hull geometries and explosive charges. The results were unambiguous. A V-shaped hull deflected the blast wave sideways. The energy that a flat hull transmitted vertically was redirected horizontally along the angled surfaces. The soldiers above survived. The engineering principle was not complicated. It was the application that required courage, because building a vehicle around a V-hull meant abandoning the conventional wisdom of armored vehicle design. Every established military vehicle used a flat floor. The flat floor was structurally simple, maximized interior space, and was compatible with existing manufacturing techniques. A V-hull was structurally more complex, reduced interior space, and required different manufacturing methods. The Rhodesian engineers built it anyway. The first generation of mine-protected vehicles emerged from Rhodesian workshops between 1974 and 1976. The Leopard, the Crocodile, the Kudu, all V-hulled, all built from available materials, all effective. Soldiers who had been dying in Land Rovers were surviving mine strikes in these vehicles. The data was overwhelming. Then came the Casspir. The vehicle that would carry the V-hull concept to its logical conclusion was not Rhodesian. It was South African, developed by the South African Police and the Council for Scientific and Industrial Research beginning in 1978. But its intellectual heritage was entirely Rhodesian. The engineers who designed it had studied the Rhodesian vehicles. The principle was identical. The execution was more refined. The Casspir was designed from the outset as a purpose-built mine-protected carrier, not a truck with armor added, not a vehicle converted from civilian use, a machine whose primary reason for existence was to keep the people inside it alive when the ground beneath it exploded. The hull was a monocoque V-shaped steel structure. The V ran the full length of the vehicle, from front bumper to rear. The angle was carefully calculated, too shallow, and the blast energy was not sufficiently redirected. Too steep, and the vehicle became unstable. The Casspir used a 17-degree angle from vertical on each side, creating a 34-degree included angle at the base of the V. That geometry, refined through testing with actual explosive charges, became the template for every mine-protected vehicle that followed. Power came from a Mercedes-Benz OM352 six-cylinder diesel engine producing 123 horsepower. The Casspir was not fast. Maximum road speed was 90 kilometers per hour, but it had range. 850 kilometers on a single fuel load. In the operational areas of southern Africa, where distances were vast and resupply was difficult, range mattered more than speed. The vehicle was 4x4, simple to maintain, and built from components available in the regional supply chain. Combat weight was 12,600 kilograms. The crew compartment seated 12 soldiers plus a driver and commander. The windows were bulletproof polycarbonate. The doors were armored steel. The roof was fitted with observation hatches. The vehicle rode high off the ground, increasing the distance between the hull floor and a buried mine, giving the V-hull geometry more room to work. Field testing against actual TM-46 anti-tank mines produced results that no one in the international defense establishment had predicted. A Casspir could survive a direct hit from a TM-46 with all occupants alive. The same mine that had been destroying flat-bottomed vehicles and killing every soldier inside was now detonating beneath the Casspir and being turned away. South African police units deployed the Casspir along the Namibian border. South African army units took it into Angola. In every engagement, in every mine strike, the pattern held. The V-hull worked. The South African Defense Force ordered 2,400 Casspirs between 1980 and 1995. Police units operated them across southern Africa. The vehicles accumulated a combat record that was unprecedented. More than 2,000 mine strikes were recorded across the fleet's operational life. In the vast majority of those strikes, all occupants survived. The numbers were so dramatically better than any comparable vehicle that they became a benchmark. When defense establishments around the world began studying mine protection in the 1990s, the Casspir data was the starting point. The vehicle's design was the proof of concept. Australia was one of the nations that studied it. When Australian defense planners began the program that would eventually produce the Bushmaster in the early 1990s, they sent observers to southern Africa. They examined Casspir data. They interviewed crews who had survived mine strikes. They came home and wrote a specification that required a V-hull. Not as one option among several, as a mandatory requirement. The Bushmaster's V-hull was derived directly from the Casspir's geometry. The angle was refined, the steel was higher grade, the monocoque construction was improved, but the principle was identical. Draw a line from the Casspir's hull to the Bushmaster's hull, and it is a straight line. Draw a line from the Casspir's hull to the vehicles that saved Zelensky's paratroopers in Kharkiv, and it is the same line. The Casspir's influence extended beyond Australia. The South African RG-31 Yala, widely used by United States and Canadian forces in Afghanistan, was a direct Casspir derivative. The American MRAP program, that produced 27,000 mine-protected vehicles for Iraq and Afghanistan, was built on V-hull geometry, proven in the Casspir. The British Mastiff, the German Dingo, the Italian Lynx, every mine-protected vehicle, fielded by NATO forces in the post-2001 period, traced its intellectual heritage to the same source. A V-shaped hull tested against TM-46 mines in southern Africa in the late 1970s. The Casspir also produced one of the most consequential humanitarian applications of military technology in the 20th century. After the apartheid era ended and southern Africa's wars wound down, Casspirs were repurposed for landmine clearance operations. The vehicle's mine protection made them ideal platforms for humanitarian demining in Angola, Mozambique, and Namibia. Regions that had been uninhabitable because of buried munitions were cleared using vehicles that had originally been built to survive those same munitions. The Mine Advisory Group and other humanitarian organizations operated Casspir-derived vehicles in demining programs that cleared millions of square meters of contaminated land across southern Africa and later in Cambodia, Lebanon, and the Balkans. The vehicles that had been built to protect soldiers from mines became the tools that removed mines from the earth entirely. Production of the Casspir ran from 1980 to the mid-1990s. Approximately 2,400 were built. The vehicle was operated by South Africa, Namibia, Uganda, Peru, India, and several other nations. Surplus. Casspirs were exported widely after South Africa's military drawdown in the 1990s. Some remain in service today. Uganda operates refurbished Casspirs for counterinsurgency operations in the north of the country. Peru deployed them against Shining Path remnants in the Apurimac Valley. In South Africa itself, police units retained Casspirs for crowd control and rural operations well into the 2000s. The vehicle that made the Casspir possible was itself a product of necessity. Rhodesia, in 1974, was a country under siege, cut off from the international arms market, forced to solve its own problems with its own resources. The engineers who designed the first V-hulled vehicles were not working from a theoretical framework. They were responding to a weekly death toll. Their soldiers were being killed by a specific weapon in a specific way. They found a solution. That solution, tested in the dust of Rhodesia and refined in the operational areas of Namibia and Angola, is now standard equipment in every modern military. The United States Army will not purchase a mine-protected vehicle without a V-hull. The British Army specifies V-hull geometry in its protected mobility requirements. Australia mandated it in the Bushmaster. Canada adopted it in the LAV III's underbelly protection. Every nation that has sent vehicles to Ukraine has sent vehicles that owe their survival geometry to the engineers who worked in Rhodesian workshops 50 years ago. The Casspir is not famous. Outside specialist military history circles, almost no one has heard of it. The country that first proved its principle no longer exists. The war it was built to fight is over. But the shape it introduced to the world, the V beneath the floor of every mine-protected vehicle on every battlefield from Helmand to Kherson, is still doing exactly what those engineers intended. It is turning the blast away. It is keeping the soldiers alive. The Bushmaster that Zelensky asked for by name in March 2022 would not exist without the Casspir. The LAV III hunting Russian supply lines in eastern Ukraine carry V-hull geometry that traces directly to southern African mine warfare. The Pink Panthers, the MRAPs, the RG-31s, the Mastiffs, every vehicle built on the principle that the floor beneath the soldiers should deflect rather than transmit the blast. It all begins in Rhodesia, in 1974, with engineers under embargo, soldiers dying, and a problem that required a solution that did not yet exist. They built the solution. They drew a V beneath the crew. And 50 years later, that V is still saving lives.